What is equivalent? Well, we're going to dig into that concept today, but we're going to focus using just the area model. And we're going to be talking about equivalent fractions. So equivalent, if you look at that word, it's very similar to the word equal. Both of them start with that EQU. So if you know what equal means, use that and you will know equivalent. Equivalent means that they're equal in value, just like equal means same as. So this is our equal sign, and we're going to dig deep into what do we use it for. So when we use that equal sign, it means the value of this side is the same as the value on the other side. So if I put a 3 here, what is equal to 3? Well, I could put another 3 because 3 and 3 are equal. Or if I put a 3 on this side, I could say 2 plus 1 is the same as that 3, or 4 minus 1, 3 times 1. Any of those things could go on this side if I have a 3 on this side because the value of those are the same. So when we're thinking of fractions and we talk about equivalent fractions, we want those fractions to have the same value. So a fraction that is equivalent is two fractions that have the same value, the same meaning, which means they could take up the same amount of space. So if we're talking about that area model like today, or if you remember the linear model, two fractions that represent the same distance, that would be an equivalent fraction. They may not have the same exact numerical notation, but the meaning, the value, the amount of space, the distance would be the same. That makes equivalent fractions. So let's look at these two circles. The circles are the same size. This one I divided into just two sections. We can quite easily say, oh, this green part is 1/2. That means this white part is 1/2. Now this circle down here, yes, there is a line that divides it in half. But I put another line here, which means now I have 4 pieces. I colored in 2 out of the 4 pieces, if I count the 4 pieces. But if you also look, if I just keep this line up and down in my mind, and I pretend this line doesn't exist, and I think back, well, if I only look here, it's kind of like this one up here where there's this half and this half. So I could also say that 1/2 of my circle is green, or 2/4 is green. It would be the same amount of space, which means they have the same value. Now, so I can use my pen. That means that 1/2 with my circles, because we're talking about the same whole, is the same as 2/4. Because if you look, if I focus on this one and I just pretend this line is the only one that I drew, then this would be 1/2. But because I did put this other line, I could also say, well, here's a 4th, and here's a 4th. So technically I have 2/4 colored, which is the same as this 1/2. That makes them equivalent, equal to the same value. In this case, the same amount of area is colored in. So let's look at how we can find out some more equivalent fractions. This is my pieces that I'm going to use, and I'll pull them on this side to work on them. So let's pull this one out. Okay, here I have a square. Let's first find the fraction that is represented as is. How many columns do I have? Okay, did you say 3? Okay, since there's 3 columns, I'm going to first be counting thirds. How many thirds are colored in blue? Did you say 1? Okay, so this blue piece right here is definitely 1/3 because my whole square is divided into 3 sections. I am focused in on the colored part right here, that's blue, and that's 1. So 1 of my thirds is colored, so 1/3. But let's say I want to find an equivalent fraction. I'm going to use the same whole. I just want to divide my whole differently. So let's say I come over here and I'm now going to draw a line across the middle. Same whole that I'm talking about, my 1 square. Now, how many pieces do I have? Well, let's count them. 1, 2, 3, 4, 5, 6. So now my whole is divided into 6 pieces, which means those are called sixths. Now, I'm still focused in on the blue. So how many of my sixths are blue? Well, here's 1/6, 2/6. So I would say 2/6 is blue. Since I'm still talking about the exact amount of space that I was in the third when I was just looking at my columns, I can say with this square, 1/3 of this square is equivalent to 2/6 of this square. So 1/3 is equivalent to 2/6. Let's try another one. I'm going to clear my board and we're going to pull out a different model, a different area model. So let me get my pointer. So we did this one. So let's work on this one over here. First, let's find out what fraction of my square is colored red. Well, how many pieces did I divide my whole into? Let's count. 1, 2, 3, 4, 5. Since there's 5 pieces, I know that I am talking about fifths. Since I'm focusing on the red, I have to know how many red fifths are there. So let's count them. 1/5, 2/5, 3/5. Okay, so I now know that looking at my square, 3/5 of my square is red. Well, I want to find an equivalent fraction, which means I'm going to take that exact same square and I am going to partition it differently. But I'm still going to be focused in on the exact same amount of space. So again, I'm going to come up here and I'm going to divide. Hopefully you can draw a line a lot straighter than mine. And I'm going to partition it right down the middle. So now, how many pieces did I partition my whole into? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this time I'm going to be counting tenths. Again, I am focused on the exact same amount of space. What's colored red? So how many of my tenths are red? Let's count. 1, 2, 3, 4, 5, 6. So when I look at my square, I can now see that my 3/5 is the same value, the same amount of space as 6/10, because I'm talking about the exact same square and the exact same amount of space. I just partitioned it differently. I went from just 3 rows here to 6 different pieces. Do you see that? Where I had my entire square partitioned into 5 rows, and then I changed it, same square, and partitioned it into 10 pieces. Same square, focused in on the same amount of space, but because I partitioned it differently, I have to notate it differently. But the value is the same. That means 3/5 is equivalent to 6/10. Let's do one more. I'm going to get one that's a little bit different to partition. So let me get my arrow and move this one out of the way. And let's do this. Let me get this out of the way so we can see it a little bit better. All right, so let's do this rectangle here. Again, we're going to figure out, just as it is, what fraction is colored in. First things that we do, we have to know, how did we partition the whole? The whole is the entire rectangle. How did I partition it? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 pieces. That means I've partitioned this into 8ths. I want to focus in on the part that is purple. How many pieces are purple? That's right, 2. 2/8 of my entire rectangle is colored purple. 2/8. If I want to know another way to say 2/8, to find equivalent fractions, I'm going to take this exact same rectangle and just partition it differently, and yet still focus in exactly on this amount of space. But remember, with fractions, our pieces have to also be the same size. That means they have to be equal. I can't just draw one line like this. Well, hopefully your line is a lot straighter than mine, where I tried to go exactly down the middle. I can't just do that there, because do you notice these pieces down here are still a lot bigger? So if I partition this top section and made smaller ones up here, I have to do the same thing to the bottom, because again, with fractions, we're talking about the same size of pieces. So again, my line, it's really hard to draw on a screen. So I'm doing the best I can to partition this evenly. So now, how many pieces do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I now have 16 pieces. And we're going to pretend that I divided all of that evenly, because my pieces do have to be the same size. And if I did go straight down the center here and straight down the center here, those pieces would be even, and there's 16 of them. I still am focused in on how many are purple. So I'm still focused in on this exact same amount of space that I did before. But because I partitioned it differently, I have to see how many of the 16ths are colored purple. So 1, 2, 3, 4. So when I had it divided into 8 pieces, 2 of the 8 pieces, 2/8, were purple. When I partitioned it, again, just differently, same rectangle, I'm still focused in on what is purple. I have to count my new sized pieces, and I got 4 of the 16 pieces purple. So I now know that 2/8 is equivalent to 4/16. So I want you to reflect. What is an equivalent fraction? Now this is an example with an area model. I want you to draw a fraction using an area model. You can choose one of these over here that I did not use, or draw your own. Color in part of it. Write the fraction that matches what you colored in. Now, in that exact same area model that you just did and that you just labeled, I want you to partition it differently. Still focus in on the same part that you colored. And what is that new fraction? I want to see if you can find an equivalent fractions using an area model.